Jahnavi from BTech second year of ECE branch B section. Now I am discussing about common emitter configuration. Common emitter configuration. First of all, what is transistor? A transistor is a three-terminal device. The three terminals are emitter, base, and collector. Here, emitter means heavily doped, base means moderately doped, and collector means lightly doped. In common emitter configuration, input we have to take input as base and emitter, and output is taken as collector. Therefore, emitter terminal is common to both input and output. Means here in common emitter configuration, emitter terminal is grounded, means common to both input and output. Here the input is taken as base terminal, whereas the output is taken as collector terminal. Next, this is the circuit diagram of common emitter configuration. Here we have to take NPN transistor. Here the input is base VBB and the output is collector VCC. Here the emitter terminal is grounded, means common to input and output also. This is the VBE base voltage and VCE collector voltage at the output. IB is the base current and IC is the collector current of a transistor. Here we have to take NPN transistor. The input characteristics of common emitter configuration. The input characteristics is the relationship between input current and input voltage. Here the input current is IB and input voltage is base emitter voltage VBE. First, draw vertical line and the vertical line represents y-axis. The output current or base current is taken along y-axis. In every characteristics, output current is taken on y-axis and input current is taken at y-axis and input voltage is taken along x-axis. When we draw VA characteristics, our input current is taken at y-axis and input voltage is taken at x-axis. To determine input characteristics, the output voltage VC is kept constant at 0 volts and the input voltage VB is increased from VB to different voltage levels. For each voltage of input voltage corresponding to input current is recorded. Means when we are determining input characteristics, VC is kept in 0 volts constant and VB and input voltage and input current is increased from 0 to different voltage levels. When we are taking input characteristics, output voltage VC is constant to 0 at 0 volts and thereby increasing VB and IB of a transistor. Here input characteristics. Here the y-axis is taken as IB base current and x-axis is taken as VB base emitter voltage. Here VC equal to output current equal to 0 volts constant. When VC greater than 0 volts, the current is increased. This is the input. Here IB is taken as microamperes, VB is taken as volts. Is the voltage VB at constant output. Voltage increased from 0 volts at certain level, constant. Already we have to see in previous slide. Voltage VB increased from 0 volt to different voltage levels. For each voltage level of input voltage VB, the corresponding input current is recorded. The curve is drawn between. This process is repeated for higher fixed values of. Already we have seen in the previous slide. The cut-in voltage for a silicon transistor is 0.7 volts and germanium transistor is 0.3 volts. It is a silicon transistor, so from the above graph, after 0.7, a small increasing initially both voltages and current does not increase when it reaches to 0.3 volts for germanium diode and 0.7 for silicon diode. It increases the current rapidly. In common emitter configuration, the input current is very small as compared to the input current, i.e. in common base configuration. The input current in CE configuration is measured in microamperes, whereas the input current in CB configuration is measured in milliamperes. Mostly we are using common emitter configuration in electronic circuits because common emitter configuration has high current gain. In common emitter configuration, the input IB is produced in the base region. Input is base and output is collector. This is about the input characteristics of common emitter configuration. Due to forward bias, the emitter base junction acts as forward bias diode reverse bias, and the collector junction acts as reverse bias. Therefore, the width of the depletion region at the emitter base junction is very small, whereas depletion region at collector is very large. Voltage across junction is further increased. The depletion width further increases. The region is lightly doped as compared to collector region. Here, the base is lightly doped. The base is moderately doped, and the collector region is lightly doped. Next, output characteristics, common emitter configuration. Previously we have seen input characteristics. Output voltage is kept constant to 0 at 0 volts. Here in the output characteristics, output current and output voltage we have to take, and output current is at y-axis and the output voltage is at x-axis, where we have to take the output current is taken along x-axis. This is also said. To determine the output characteristics, the input current or base current is kept constant at 0 microamperes and the output voltage VC is increased from 0 volts to different voltage levels. Means when we are taking output characteristics, we have to kept IB input current IB equal to 0 at 0 microamperes, and the voltage of VCE is increased from 0 volts to different voltage levels. For each level of output voltage, the corresponding output current is recorded. For each output voltage, the corresponding current is taken, and it is drawn between the graph is drawn between IC and VC at constant input IB equal to 0 microamperes. Next, when the base current or input current IB equal to 0 microamperes, the transistor operates in the configuration cutoff region. In this region, both junctions are reverse biased. In output characteristics, we have three types of regions are formed: cutoff region, saturation region, and active region. If both base emitter junction and collector base junctions are reverse biased, then it is called cutoff region, and base emitter base junction and collector base junction both are forward biased, then it is called saturation region, and emitter base junction is forward biased and collector base junction is reverse biased, then it is called active region. Next, the input current IB is increased from 0 microamperes to 20 microamperes by adjusting the input voltage VB. The input current is kept constant at 20 microamperes. While increasing the input current, the output voltage is kept constant at 0 volts. After kept the input current IB constant at 0 volts. This is all we have to see in previous slide. These steps are repeated for higher fixed values. When we are kept IB equal to 0 volts constant in the output characteristics, the voltage increases to 40 micro, 60, 80, 100, like that. Next, this is the output characteristics of common emitter configuration. Already we had to see what is saturation region, active region, and cutoff region. Cutoff region means there is no flow of any current, means emitter base junction and collector base junction both are reverse bias. Active region means emitter base junction and collector base junction. Emitter base junction is forward bias and collector base junction is reverse bias. Saturation means both emitter base junction and collector base junction are forward bias. Here, the y-axis is taken as IC collector current in milliamperes, and x-axis is taken as VCE collector to emitter voltage in volts. This is the output characteristics of common emitter configuration. This is all about where we have to see is common emitter configuration. Thank you.